Hello ladies and gentlemen, we're going to do 13.4. We're going to evaluate inverse trig functions. So what we're primarily going to do is now find the angles instead of the ratios or the lengths of the missing sides. Okay, so let's say I start with a diagram. Here's my handy dandy little triangle, and here's my theta, and there's a 3, a 4, and a 5. This time I want to find the measure of theta. So I could do the sine of theta is equal to 4 over 5, or I could do the cosine of theta is 3 over 5, or I could say the tangent of theta is 4 over 3. I can't divide by theta to solve, but what I can do is do the inverse. So I could say theta is equal to the inverse sine of 4 over 5, or I could do theta is equal to the inverse cosine of 3 over 5, or I could do theta is equal to the inverse tangent of 4 over 3. All right, so those would be my three possibilities. Okay, so let me show you on your grapher. We're going to do these in degrees, so I'll scoot it over here. So the first thing I want to do is check my mode and make sure that I'm in degrees. And then my inverse trig functions are up above the regular trig functions. So I'm going to do the inverse sine, and I'm going to do 4 divided by 5. So I'm going to get that theta is equal to 53.13 degrees. Okay, and then I'm going to show you that I can get that same answer using the other ratios. I just have to be careful in how I set up my ratios. So I could do the inverse cosine of 3 divided by 5, and I got the same answer. Or I could do the inverse tangent of 4 divided by 3 and get the same answer. I could also go to the mode button on my calculator and turn it into radians, okay, and I'm just going to repeat the last operation that I just did. Okay, so we were saying that theta was equal to 53.130 degrees. If I put my calculator in radians, I also know that that's equal to 0.9273 radians. Okay, so it's kind of an easy switch if you want to change the modes on your calculator. All right. So now let's do a couple of examples on finding the measure of the angle. Okay, so I want to find the measure of the angle. Okay, so for number 1, here's theta, and I have a 6 and an 11. I'm going to do the cosine of theta since I know the adjacent, so the cosine of theta is 6 over 11. Then theta is going to equal the inverse cosine of 6 over 11. I'm going to do it just in degrees just to save time, and I'm going to get 56.944 degrees. Okay, remember we always do 3 decimal places. All right, the next example, my cords are kind of in the way. Here's my triangle. Okay, this time I know theta is up here, and I know this piece is a 9, crappy drawing, sorry, and there's the 4. So I'm going to do the tangent of theta because I don't know the hypotenuse, and it's going to be opposite over the adjacent. So theta is going to equal the inverse tangent of 4 over 9. The inverse ratios are always used to find an angle, and I'm going to get 23.962 degrees on my handy dandy grapher. Okay, the third triangle, I'm going to have a Pythagorean triple, so this would be actually 5. It's not a Pythagorean triple, I lied. We'll put the 12 out there. So now because I know the opposite, I'm going to do the sine of theta is opposite over 12, and so theta is going to be the inverse sine of the 5 over 12. Use my handy dandy grapher, and I would get 24.624 degrees. Okay. So that's how we do that in our calculator. So now let's switch and let me show you how we do these with our special right triangles. Okay? A couple of things that we have to know first. So we have to know some additional stipulations for sine, the inverse of sine, the inverse of cosine, and the inverse of tangent. So let me draw a little sketch of my unit circle. This is 0, this is pi over 2. And then if I do the opposite rotation this way, this is going to be a negative pi over 2. Inverse sine is limited, really bad picture, sorry, to those two quadrants, okay? So we would say that for inverse sine, if I have a negative pi over 2 is less than or equal to theta, less than or equal to pi over 2. So that would be something that you just have to memorize. It comes from the graph of the sine function, but we're not going to talk about that just yet. All right, so then if I do my cosine, my arc cosine or inverse cosine, sorry, that's a word this book doesn't use. Okay, I'm going to draw my quadrant system. There's my unit circle. So this is 0, pi over 2, and pi. The inverse cosine is limited to the top half of the circle. So it's limited between 0, less than or equal to theta, less than or equal to pi. All right, and again, this is just something you have to memorize. And now let me show you the inverse tangent. Okay? Inverse tangent, I draw the same unit circle, and again, this is pi over 2. The coordinates of that point are 0, 1, and the coordinates of that point down there are 0, negative 1. Remember, we're in the unit circle, so the radius of that circle is 1. And tangent, just like sine, is limited to the right half of the circle. So I would say that tangent is limited to a negative pi over 2, less than or equal to theta, less than or equal to pi over 2. All right, so that's kind of the background information. There's a lot more information that I could tell you, but I'm just going to limit it to this for right now. The only other thing that I would tell you is we would say that inverse sine is limited to quadrants 1 and 4. Inverse cosine is limited to quadrants 1 and 2. And inverse tangent is limited to quadrants 1 and 4. Alrighty, so now let me do a couple of examples for you. And these are all going to be done with our exact triangles, so they're going to be done by hand. So the generic directions are going to say evaluate the expression by hand. All right, and for these, I'm just going to do them in radians. I'm not going to do the degree equivalents, so you'll just have to pay attention to the directions in the classwork because sometimes they want you to do both. So our first problem is going to be the inverse cosine of a radical 3 over 2. Okay? We always do these with a diagram. I know that inverse cosine is limited to the first and the second quadrants, so I'm going to draw a picture. Cosine, okay, so I'm going to draw my picture, and I'm going to draw my picture. This is where cosine is limited. This could be an angle, and this could potentially be the same angle. Okay? Cosine, the ratio is the adjacent over the hypotenuse, which means that that piece is 1 because there are specials. Opposite the 1 is a 30-degree angle, so that means this is pi over 6. Okay? Over here, the cosine would be a negative 3, and so already I know that that's not going to give me the same ratio as this, so this option is not possible. So my theta is going to equal pi over 6, so this is my solution. And I did it by kind of doing the problem backwards from what we've done in the past. All right, so let's do another one of these. Now I'm going to say the inverse tangent of a radical 3. They didn't put it over 1, but I'm going to put it over 1 just so we're used to seeing that. I know that arctangent or inverse tangent is limited to the first and the fourth quadrants. So that means that I could potentially have an angle up here, okay, and tangent is y over x, so it's going to be radical 3, 1. That means the hypotenuse is 2. It could also potentially be down here, okay, so there's always two locations for the angles potentially. But notice if I do this, the y piece becomes negative, therefore this piece doesn't work. Okay, opposite a radical 3 is a 60, so this is pi over 3. So I would say that theta is equal to pi over 3, which is why we've been learning to draw our angles and label everything, because now I have to be able to go backwards. Okay, the next one is going to be the inverse sine of a radical 2 over 2. Now that looks a little bit different than what we've been doing, But if I unrationalize this, this is the same thing as the inverse sine of 1 over radical 2. Okay? Inverse sine is limited to the first and the fourth quadrants. So sine y is positive up here. So I'm going to have 1 over radical 2. That means this piece is also 1. So this angle is pi over 4. Inverse sine can also be down here in the third quadrant, but if I drew that angle, sine is negative down here, the y is negative, therefore this piece doesn't work. So my theta is pi over 4. Okay? All right, and I have one more example for you. All right, this one says the inverse cosine of 1/2. So we always start with our diagram. Arc cosine is limited to the top half. Cosine is positive in the first quadrant because cosine is x over the hypotenuse. That means this is radical 3. It potentially could be over here as well, but over here the x is negative, so this piece doesn't work. All right? My theta is here. Across from the radical 3 is a 60, so this is pi over 3. So my theta is equal to pi over 3. Okay? So that's how we do it with our diagrams and not using our calculators. And I'm pretty sure the book is really good about telling you when to use your calculator and when to do it by hand. So let me give you your problems for the day. Okay? I'm going to start with the set that we just managed. So the first piece is going to say find the measure of the angle in degrees and radians. Use the special right triangles and reference angles to help. You also have to remember where inverse sine is limited to, where inverse cosine is limited to, and where inverse tangent is limited to. All right, so the first problem says find the inverse sine of 1/2. Okay, and notice they want it in both degrees and radians. Okay. And then number 2, I'm going to have the inverse cosine of a negative 1/2. Alrighty. The next two say find the measure of the angle in degrees and radians. Okay. Notice again they want both degrees and radians. So problem number 3, here's your handy dandy little triangle, okay, almost a triangle. This is 1, this is 6, and there's theta. And then for number 4, here's your triangle. Okay, oops, I guess you can't see that, so sorry. All right, here's the last 2, and here's theta, and this is 15, and the hypotenuse is 33. All right, so good luck with your problems, and I will see you tomorrow.